Hi everyone, welcome back to Math Academy. In this video, we're going to solve a challenging algebraic equations. In this video, we're going to find all triple of x, y, and z integers such that x squared times y minus z plus y squared times z minus x plus z squared times x minus y equals to. In the first step, we need to multiply y minus z by x squared, z minus x by y squared, and x minus y by z squared. So we get this expression. In the next step, we can factor x from the terms under which there is a red line, and also we can factor out y from the terms under which blue line. If you look at the first parenthesis and the second parenthesis, we can say if we add the minus yz to the expression in the first parenthesis and add xy to the expression in the second parenthesis, we are going to get same expression in our parenthesis. Notice that we add minus yz to first parenthesis. We need to add plus yz to our parenthesis, also plus zx to the second parenthesis, because we don't want to change our variables. Now we can multiply x by yz and minus y by zx. xzy and minus zyx is going to cancel out. And as you can see, we get same expression in the first parenthesis and the second parenthesis. Now we can factor x from the first term and the second term, and factor z from the z squared and minus yz. Y minus z is common in two terms, so we can factor y minus z. So we get y minus z times x minus z. For the second parenthesis, also we can factor y from these two terms and z and minus z from the z squared and minus xz. So we get y minus z a common in our terms, and we can factor y minus z, and finally we get y minus z times x minus z. The red terms is common in the first term, the first expression, and the second expression, so we can factor it out. We are going to get x minus y times y minus z times x minus z equals 2. Now we need to looking for three integers numbers that the product of these three integers becomes 2, and also we can say x minus y plus y minus z equals x minus z, because minus y and plus y is going to cancel out, and we get x minus z. Now we can say we need to looking for three numbers such that the multiplication of these three numbers becomes 2, and the add the sum of the first and the second terms become the third terms. As you know, we can write 2 equals the 1 times 1 times 2 minus 2 times 1 times minus 1 and 1 minus 2 times minus 1. As you can see, the multiplication of these 3 terms equals 2, and the sum of the 1 and 1 becomes 2, minus 2 and 1 becomes minus 1, and 1 minus 2 becomes minus 1. In the next step, we can put x minus 1 equals 1, y minus z equals 1, and x minus z equals 2. Also, we can write x minus y equals minus 2, y minus z equals 1, and x minus z equals minus 1. Finally, we're going to get 3 system of equations. Now we want to solve the first system of equation. If we multiply the third equation by minus 1, then add the first equation by the third equation, x minus x and minus x is going to cancel out, and we get minus y plus z equals minus 1. The second equation remains. As you can see, if we multiply the y minus z equals 1, this equation, by minus 1, we get minus y plus z equals minus 1, and these 2 equations is going to same. So we can say this system of equation has infinite many solutions, x, y, and z. Now we need to find the relation between x, y, and z. From this equation, we can write x equals y plus 1, and from this equation, we can write z equals y minus 1. So if we name y equals k, x becomes k plus 1, and z becomes k minus 1. And this system of equation has infinite many solutions such that x, y, and z, the relation between x, y, and z is k plus 1, k, and k minus 1. Also, by using the same way, we can find the solution of this system of equation and this system of equation. This system, if you solve this system of equation, you're going to get this equation. This system of equation has infinite many solutions such that x, y, and z, and the relation between x, y, and z is k, k minus 1, and k plus 1. Also, the third system of equation has infinite many solutions that x, y, z, that the relation between x, y, and z is k minus 1, k plus 1, and k. Notice that k is integer. So we can say our algebraic equation has infinite many solutions such that x, y, and z, which the relation between x, y, and z can be k plus 1, k, k minus 1, or k, k minus 1, and k plus 1, or k minus 1, k plus 1, and k is integer number. Thank you for watching this video. Please subscribe, like,